This is just a small addendum to the Euler angles video. Recall that we defined x, y, z Euler angles by rotating the axes in sequence about the current x-axis, then the current y-axis, and then the current z-axis to go from frame 0 to frame 3. So this is x, y, z Euler angles. And then because it's a sequence of 3 elementary rotations, we can construct the full rotation matrix as a product of these 3 elementary rotation matrices, each of which is a function of the corresponding angles by which we rotate alpha, beta, gamma. So let's actually write an expression for the final rotation matrix just for simplicity. So just for completeness. So x, y, z Euler angles, alpha, beta, gamma. So r 0 to 1 is basically a rotation about ex naught by angle alpha. So it's going to have this expression cosine alpha minus sine alpha, cosine alpha. Okay, so that's E0 to 1, R0 to 1, R1 to 2 is a pure rotation about the y-axis, y1 axis, and the rotation matrix is going to be cosine beta 0, sine beta 0, 0, 0, minus sine beta, cosine beta 1. Okay, so that's, recall, that's the rotation matrix for a pure rotation about y, as we discussed. And then a pure rotation about z is what R2 to 3 is. And that's by angle gamma. So we have 0, 0, 1, 0, 0. And we have cosine gamma minus sine gamma, cosine gamma. Okay, so those are the 3 component matrices, and of course are the full rotation matrix that takes you from frame 0 to frame 3, like we discussed, is the product of, well, first we apply R0 to 1, then we apply R1 to 2, then we apply R2 to 3. So this acts on the result of this, and this acts on the result of these two together. So that's why it's in the sequence. And then we can, so the net rotation matrix is a product of these 3 individual rotation matrices in this particular order, right? So we have to maintain the order of rotations. If we do not, it will be a different Euler angle set. For Euler angles, the order of rotations matters a lot. Okay, so that's it. So that's how we construct the full rotation matrix. This is how to go from Euler angles, specifically XYZ Euler angles, to the corresponding rotation matrix. Okay.